Hey guys, here's a video that's going to help you work through a couple of problems in the homework for finding the tangent lines for certain equations. This is again as part of the application module of the derivatives that we're looking at. So what makes this one unique is the instructions here. It says the graph of the function is shown below. Use the tools to graph the line tangent to f of x at x equal -1. So the negative 2x to the third plus x minus 3, that's the graph, that's the blue curve here. And what we're supposed to do is take these dots and put them in a place so that our red line is tangent to this. In other words, it touches this blue curve at only one place. And we're focused in on where x is -1. So here's how we're going to attack this problem. There's three steps that we want to look at. First, what we want to do is we want to find out what the equation is that I'm supposed to graph. So here is where we're going to begin. We're beginning with this equation, y minus y1 equals mx minus x1. This is just our basic equation for a line. We call this point slope, and you may remember that from some of your algebra classes in the past. M, we all know to be the slope of that line. And here's the punch of this problem. This line is a tangent line. This is the slope of that tangent line. That phrase, the slope of the tangent line, is what implies that we need to find a derivative. So a derivative is the slope of that tangent line. So our first step is going to be find the derivative at an x value of -1. So step one, take the derivative, plug -1 in. Now, what we're also going to do is we're going to replace y1 and x1 with appropriate values. That'll be what we do in step 2. And then step 3 is to take that information and get x by itself here, okay? So we're going to take a look at some of this stuff I've already gotten written out and see if we can't help you guys get to the right answer and how to use that graphing tool in Newton. So we'll begin with the derivative of this thing, f prime of x is equal to -6x squared plus 1. The derivative of 3 is just 0. So we'll plug in we'll plug in -1 into the derivative. So -6 times -1 squared plus 1. -1 squared is 1 times -6 is -1. So our slope here is going to be -5. We could go ahead and write in some of this information here. Y minus something, -5x minus something, okay? So that is the first step. It's really kind of the calculus part of this problem, finding the derivative and plugging in -1. The next part of our problem is to take the x and y value and plug those into this equation that we've got right here. Now we know our x value is -1. Notice that I put that into the equation using parentheses. That's just something I encourage my students to do, is when you're plugging a negative value into an equation, use the parentheses. It'll help you keep up with your negative signs. What we don't know is the y value though, so we're going to take -1 and plug it into the original equation. Notice this is not the derivative, it's the original equation. So -1 to the third power is -1. And when we multiply that by -2, we get a +2. 2 minus 1 is going to be +1, and 1 minus 3 would be -2. So the value we should plug in here is a -2. So let's simplify this equation a little bit. So we'll have y plus 2 equals -5x plus 1. We're going to distribute that -5. So y plus 2 equals -5x minus 5. And then we'll subtract that 2 from both sides, -5x minus 7. So now I have an equation that I can use over here to graph. So we're going to graph the equation, again, we're going to graph that equation, -5x minus 7. So we'll take our y-intercept and we'll go down here to -7. We'll take this other point, and remember we can go down 5 and write 1, or we can go up 5 and write 1. Okay, so notice you're at this point here. This is the line that is tangent to the blue curve at that point, -1, -2. We'll submit, and hey, correct, we nailed it. Okay, I hope this problem helps you work through some of these assignments. Let me know if you have any questions.